So let me take you through an example now. And in this example, here you've got a picture. I'm going to assume a few things to make it easy. The first thing I'm going to assume is that we've got these little edge elements, these gradients. And I'm going to assume that we know which way is inside to the edge and which way is outside. It just makes it easier for the image for indexing. So let's start by looking at all of those bottom horizontal edges that are pointing inwards. All right? So they all have the same theta. All right? Now, as we go across all those different edge elements, they each have different displacements to the center. So all of those red lines, those are all the displacements associated with being a bottom horizontal edge. So if I found a little bottom horizontal edge, I'd have to vote with all of those displacements. So what that would look like at runtime is as follows. So here I have a little edge element, and it's voting for all these different displacements, which all would lie along that line. Where did all those different displacements come from? They're all here. These were the displacements for every possible bottom edge line, so every one of those vectors have to be voted by each bottom element. So that's just one element, but of course there's the next element. It has to vote the same way. It comes from the same theta, and another one, and another one, and another one, and eventually this big long line of possible offsets are voted for. Now, I didn't indicate here, the one in the middle is actually voted for more often, so maybe you can think of the middle as being thicker than the ends, but the idea is that this line has the votes for where the center might be. We don't know where along the center it is yet. Well, now what we can do is we can take a look at the downward pointing diagonals. And you'll notice that for the downward pointing diagonals, it can be anywhere from being straight above it all the way over to the right of it. Okay? So it can be straight above it or all the way over to the right. So what this means is at runtime, each little diagonal element has to vote straight above it all the way over to the right. And that's what's represented here for the first part. And here's another diagonal element, and another diagonal element, and another diagonal element, until finally they've all stacked up. And you'll notice already I know where the object is. This is how the center was found. So the idea is that we're using this table of those offsets indexed by the gradient in order to vote for the center.